Well, hello viewers, welcome back to what Brain Builder Science. And in today's video, we're going to be talking about what now? Ionization. Okay? So now when we say ionization, we are talking about the process by which what an atom, be it a metallic atom or a non-metallic atom, forms an ion or forms a charge. Okay? So now simply put, ionization is the process whereby an atom forms what? A charge or an ion. Okay? So now if you look at this situation I have on the board, I have two case studies here. We have what metals on one side, we have what non-metals on the other side. Okay, so now these two atoms, they what carry out these two groups of atoms rather carry out ionization process, but what with some little different way, with something with a little difference in what their mechanism. Okay, so now let's look at the what metals, the group of atoms we have here, which are the metals. Okay, so now metals on this hand, metals, in order for them to carry out this ionization process, they do that by what now? Loss of what now? Electrons. In other words, metals form metals ionize by the what now? Loss of what? Electrons. Okay, so let's look at this part now. So now in this case now I have sodium atom, potassium atom, magnesium atom, calcium what atom, then we have aluminium what atom. Okay, so now if you looking at this thing carefully, when if you look at the electronic configuration based on what now? Atomic structure, something that looks like this. If you still have something that looks like this, whereby you have the word proton and the neutron in the nucleus, then you have electron revolving around the word nucleus. If you have any confusion concerning this, you can look at our previous video on valences. Okay, look at our previous video on valences, then you will have an idea about what I'm talking about. But this is what now a typical example of what now electronic configuration based on what atomic structure. If you look at that for sodium, sodium has what you discover that sodium has what one electron in its atomos shell. So now, and recall, metals ionize by the loss of what? Electron. That electron in the atomos shell is known as the what now? Valency electron. So that electron is what we call the combining power. In order for them to what form ion, they have to lose that electrons as metals. Okay. So now for metals, for sodium to form ion, it has to lose one electron. When you lose one electron, it becomes what? Positively charged. Okay. So that's the process of what now? Loss ionization for metals. They lose electrons. In this case of sodium, it's going to lose one electron. But how are you going to show that? This is what we're looking at now. So now by the time you write the sodium like this, first of all, you want to bring out especially the ion that is formed to show that it has lost electron. But the electron that is being lost, you show it here by using a plus. You now have what? E minus. Looking at this now, the product side, generally for every reaction, we have what? Reactant side and we have what? Product side. Everything on the left hand side is the reactant for general reaction, generally chemistry. Reactant side, product side. However, when you are writing this, the metal will be on the what? Left hand side. Then the product formed will be on the right hand side. Then the numbers of electrons lost, we also show it on the what? Right hand side, which is the product side. So I know it will make sense for you to say, why is there no minus sign here? However, why it logically makes sense to put minus sign that you are losing electrons? Chemistry is not so. Chemistry is not done that way. Okay, the fact that it's already placed in the product side, showing that what now it is. This is what is formed and what this electron is being what produced and what lost. Okay, that's what putting on the product side means. Okay. So now going by this other one, we also have what this atom here, this metallic atom called what? Potassium. Potassium as well. If you look at the what electronic configuration based on what atomic structure, we also discover that what potassium has atomic number 19 and it's what having what one valence electron, that means one electron in its atomos shell. So it's also going to lose the electron through a process of what ionization in order to what form what ion. So it's going to undergo the same process. We have what K plus then what E minus. Okay, just a quick note, elements that have the same numbers of electrons in their atomos shell, they tend to be on the same what group on the periodic table, or more on groups and period of periodic table in our subsequent video, but that's not the topic for now. So now looking at this now, we have one magnesium here. Magnesium, if you look at magnesium electronic configuration based on what atomic structure, we also discovered that what magnesium has what two electrons in its atomos shell. So that's what make it what a group 2 what metal. But let's leave that. So now we already know that what, with that being said, we know that what now it's going to be losing 2 electrons. So by the time you lose 2 electrons, it becomes what positively charged. This one loses 1 electron because it was plus 1 charge, right? For these two cases. But now it's going to be what? Plus 2 charge. Then the numbers of electrons being lost, 2e minus. Okay? So now I hope you're following. So now looking at this case now, calcium atomic number what? 20 of the what? Periodic table, 20 of the periodic table. If you look at this, we draw the electronic configuration based on atomic structure. We also discover that what now we have 2 electrons in the atomos shell of what? Calcium, valence electron. So it has to lose that in order to what now form what? Charges or what? Ions. Okay? So by the time it does that, it becomes what? Ca plus 2, and we have what? 2e minus. Okay, Same goes for that. But now, on this other hand, aluminium is also a metal, but looking at the atomic structure, electronic configuration based on atomic structure, aluminium will be having 3 electrons in its atomic shell. But since it's a metal, in order for it to form ion, it has to lose electrons, okay, to form ions. So in that case, aluminium case will be Al plus 3, then 3E minus, okay. That will be the case for metals. Metals replace the place the product form on the product side, then the numbers of electrons being lost also on the product side to show that it's losing it. Excuse me. Now we're talking about non-metals. Coming to this angle of non-metals. Non-metals, they, like I said, they ionize. They also carry out ionization process, okay, or in a quite different way. So now looking at this now, the non-metals, they ionize by the gain of electron. On this other hand, these people, they gain electron in order to become charged, in order to form charge or form ions, okay. And note, when they receive electron, they become negatively charged. When the neutral atom of a non-metal receives the electron, it becomes negatively charged, okay. So now in this case, now if we want to write such process, remember in the case of metal, we place the electron in the product side, which is the right hand side, to show that it's losing it. But in the case of gaining, we're going to write it like this, plus like this. But before I put the chart, let me quickly note something. Chlorine, if you look at the electronic configuration of chlorine based on atomic structure as well, we discover that now chlorine has 6 electrons in its atomic shell. Be careful. 7 electrons in its atomic shell. It has 7 valence electrons. But because it's a non-metal, it needs to attain octet configuration. Like just metal also has to do that as well. But do that by losing. But in this case now, it has to gain 8 valence electron in order to achieve an octet configuration. That's to be stable. So now in order for it to be stable now, since it has 7 already in its atomic shell, you just need 1 to complete it. By the time you receive that 1, it becomes negatively charged. As you receive that 1, now this, how are we going to write the numbers of electrons? We write the numbers of electrons by saying E minus, because it's just receiving 1, okay? Since it's receiving 1, we're going to have something like this. After adding the electrons on this side, we'll show the arrow, then it's now give you Cl minus. That's how it forms charge. This is for chlorine, because it has 7 electrons in its atomic shell. So it's also a group 7 elements, okay. So now looking at oxygen, same thing goes for it. However, oxygen atomic structure based on electronic configuration based on atomic structure, oxygen has 6 electrons in its atomic shell. So that makes it needing 2 electrons to be complete 8, okay. So now in this case, in the case of oxygen, it's going to be receiving 2 electrons, okay. But this is just 1, the 2 here coefficient to show that we are getting 2 electrons. Then we now have 2 O. Now we have something like this, O minus 2 for a single atom of oxygen. It now be O minus 2, okay? O negative 2. That's why you show that now this is the valency of this is the ion that is formed by 1 atom of oxygen. So now looking downward here now, I wrote the same thing but in a different form. This is chlorine atom, oxygen atom, chlorine molecule, and oxygen molecule. In the case of chlorine molecule, looking at this now, it's going to, of course, receive the electron. But now, in the case of atom, it receives 1 electron, and we designated it by now? E minus. But because in this case we have 2 chlorine, what this means is that 2 chlorines are bonding together. 2 chlorines are joined together. That's how they bond together to form this molecule. So definitely it's going to be taking twice the electron of 1 atom. So now in this case it's going to be taking 2 electrons. So now it will now be forming Cl minus, which is for just 1. This one I have here now is just for 1. So now in order to make it to show that now it's 2 atoms that forms the Cl minus, we're going to put a coefficient here. Now it makes sense by saying 2 chlorine ion special was formed. Okay, that's how it works. So now for the last case here, that we have here, we have oxygen. Recall from this place, 1 atom of oxygen was able to take 2 electrons. So now we have twice of it. So that means in this type of situation now, we have okay, let's say this type of situation, we have 2 oxygen bonded together. Okay, that's what formed this molecule. So now if one of this, one of it that I described here was receiving 2 electrons, that means 2 of it will be taking twice the number. So now we have E minus, which is the electron, and in this case we'll be taking 4 of it. Why? Because only 1 can take 2 electrons. Okay. So now with that being said, what will now be the total ions formed? That will now be O minus 2. However, for us to show that what now, two atoms of what now, two atoms of what, oxygen receive the two electrons in this one molecule, received it, to have what, 4 electrons to form what, two oxygen ion, two oxide what ions. Okay, you have to represent it like this. So okay, and one more thing you have to notice, concerning this what chain reaction. This is how to write them for non-metal, this is how to write them for what, metals. One more thing you have to take note of is that for metals, this is what, sodium atom, this is what, sodium ion, this is potassium atom, this is what, potassium ion, magnesium atom, magnesium ion, calcium atom, calcium ion, aluminium atom, aluminium what, ion. But in the case of non-metal, it's quite different. This chlorine atom is, by the time you have chlorine atom, this specific form that is now what, chloride. When you call it for when you are calling the name of non-metals in their ionic form, you add IDE to it. So now we have what, chloride ion, oxygen atom, oxide ion. This what, on this case now there's not atom, this is a molecule. Now this chlorine molecule, this what now, chloride what, ion, oxygen molecule, then we have what, the oxide what, ion. Okay, so now that brings us to the end of today's video concerning what now, ionization. Okay, so don't forget to hit the like and subscribe button, and we'll see you on the next one. Have a nice day.